Well, welcome back. Hopefully everybody did a good job with the like denominator section. So now we want to move on to the unlike denominator section. So we're again using the same idea of area models and number lines. The only difference is what we're going to have to do is get a common denominator before we can do the actual modeling part. So let's look at number 11 here. So use an area model to add 1/6 plus 3/4. So again, the problem with this is we've got different size pieces, so you can't just directly add them up. So what we have to do is we have to turn them into the same size pieces. So in this case, if we were using like fraction towers and things like that, we would notice that the nice common denominator for these would be 12. That's how we could break these up easily into a common denominator. So now if we rewrite these in terms of their common denominator, 1/6, we would need to multiply the top and the bottom by 2. So that's going to give us 2/12 as our new equivalent fraction for 1/6. And 3/4, we're going to have to multiply the top and the bottom by 3. So that's going to give us 9/12. So now from here, it's just like we did before. We would just want to, you know, just like adding like denominators, because that's what we have. So we want to divide this rectangle into equal pieces. So in this case, since our denominator is 12, we want to turn this into 12 chunks. So we're going to need 11 lines. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. And again, hopefully they're relatively close to the same. Again, mine aren't that great, but you get the idea. And so now what we want to do is shade 1/6, which in this problem is now turned into 2/12. So that means we need to shade 2 of these blocks. And so let me change colors. And so to add 9/12 means we want to shade 9 more. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many pieces are shaded all together? So if we count them up, it looks like 11 are shaded. So in this case, our answer would be 11 out of 12. All right, is that okay? Good. All right, so now same thing, we want to add using a number line. But again, we're adding 1 3/4 plus 7/8, so they don't have a common denominator. So the first thing we'd want to do is write these both with common denominators, so that way we have the right number of tick marks. So in this case, 4 and 8, we could just use 8 as our common denominator. So 8 is going to be our common denominator for this one. So what we want to do is change 1 3/4 into 1 6/8 by multiplying the top and bottom of 3/4 by 2. So now we're safe to actually put this on a number line. So again, let me first kind of break it up to 0, 1, 2, and 3. Since our common denominator is 8, we're going to need 8 chunks. So I need 7 tick marks. So 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And so again, first thing we want to do is we want to plot 1 6/8. So start with 1 and then count over 6 tick marks. So 1, 2, 3, 4, 5, 6. So 1 6/8 would be right there. And to that, we want to add 7/8. So again, since all of our tick marks are in terms of eighths, we can just jump 7 tick marks. So 1, 2, 3, 4, 5, 6, 7. So that puts us there. And so if we add those up, wherever we landed will be our answer. So to count that out, we're starting at 2. So 2 and 1/8, 2 and 2/8, 2 and 3/8, 2 and 4/8. So it looks like we landed at 2 and 5/8. So in this case, 5 and 8 don't simplify. So 2 and 5/8 would be our final answer. All right, is everybody okay with adding unlike denominators? All right, good. So let's do the same thing, but now we're going to have subtraction with unlike denominators. So again, in this case, we're trying to do 3/4 minus 1/3. So again, in order to be able to do this, we need to get the same denominator. So a nice common denominator for this guy will be 12. So first thing we need to do again is write each of these with a denominator of 12. So 3/4, I'm going to multiply top and bottom by 3. And 1/3, I'm going to multiply top and bottom by 4. So now that I've rewritten them, first thing I can do is go in and divide our rectangle up into 12 chunks with 11 lines. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And again, we want to plot 9 over 12, so we're going to shade 9 of these out. 5, 6, 7, 8, 9. But now, since we're doing a subtraction, instead of adding more on, now what we want to do is cross some off. So I want to cross out 4 of them. So I want to get rid of this one, this one, this one, and this one. So how many boxes do I have left? So I've got 1, 2, 3, 4, 5 out of 12. So 5/12 is left. So my final answer, again, because this doesn't simplify, would be 5 over 12. All right, very good. Oops. So again, do the same thing for our number line one. So 1 5/8 minus 1/4. Again, they're not a common denominator, so we need to do that first. So a good common denominator for this would be 8. So 1 5/8 is already perfect, but we need to turn 1/4 into a common denominator. So if we multiply top and bottom by 2, that'll give us 2 over 8, which is good. So again, first thing we want to do is divide our number line up. I'm going to do 0, 1, and 2. And then again, since our denominator is 8, we want to break this into 8 chunks. So I need 7 lines. So 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And so let's graph 1 5/8 first. So starting with 1, we'll count over 1, 2, 3, 4, 5. So there's 1 5/8. But now, since I'm subtracting, I want to go to the left and I want to subtract out 1/4. But since I want to think of it in terms of eighths, I'm actually getting rid of 2 eighths. So it means I want to jump 2 tick marks to the left. So I'm going to jump there. So wherever we landed is going to be our final answer. So again, starting at 1 and counting up, we've got 1 1/8, 1 2/8, 1 3/8. In that case is where we landed. And again, 3 over 8 can't be simplified, so our final answer would just be 1 3/8. All right, good job, everybody. So again, I'm going to leave some of these for you guys to do. So 15 and 16, I think, are going to be the exit ticket for this week. And the word problems, I'm going to put all those guys in the collaboration space. So first come, first serve on the word problems. So jump in, write down your solution and things like that. So there's enough word problems that everybody should be able to do one. If you have any questions, I'll be around all day tomorrow. So good luck.